So today we're going to cover section 2. Today we're going to talk about areas of circles and areas of sectors. So the first thing we're going to do is take a look at the formula for area of a circle. And that formula is pi times the radius squared. Again, where r in this formula represents the radius. Now, for this formula, there's not 2 like we had for circumference. So you need to be able to understand that if you're given a diameter, you need to be able to turn it into a radius. So just remember, if you're given a diameter, you will divide it by 2, and then that turns it into a radius. The units on area questions are always units to the second power. So when you label your units, if it's inches, it'll be labeled as inches squared. Next, we're going to define what a sector of a circle is, and then we'll see what the formula is, and then we'll do examples. Next, let's define what the sector of a circle is. So a sector of a circle is the region bounded by 2 radii and their intercepted arc of the circle. So what it's talking about is just a portion of the circle. So that, I guess, tan-looking color is like a piece of pizza. So before, when we did the arc length, we were measuring the crust of the pizza or the outside edge of the circle. Now we're talking about the area, so we're talking about this whole section here. And again, it's only a part of the circle. Next, we'll see the formula for the area of the sector on the next slide. So the area of the sector is the ratio of the area of a sector of the circle to the area of the whole circle, which is pi r squared. And it's equal to the ratio of the measure of the intercepted arc to 360. So to simplify what's in here in the white part, all you're going to do is define area of a sector. You're going to do the measure of the arc divided by 360, just like for the length of the arc, times by the area formula, pi r squared. Now, if they give you the area, then what you could also do is, just like we did with circumference, multiply it by the area. And this area of the sector, again, just like before, it's the units squared when you go to write your final answer. So it's either they're going to give you the area already calculated, and maybe they'll ask you to find the measure of the arc, or you would use the formula, pi r squared. So again, area of the sector. Okay, so for the first one, it says to find the area of the circle with a radius of 4.5 meters, and it wants us to leave our answers 2 ways. It wants us to leave our answer in terms of pi and also calculate the area using your calculator. And I'm going to round to the hundreds place. So if it doesn't specify, whenever they give you questions, then round it to the hundreds place, unless they tell you a specific place. So again, the formula that we're going to be using for these 2 questions is going to be area is equal to pi times the radius squared. Now, if you'd rather memorize it as radius squared times pi, that's perfectly fine, because again, remember, multiplication is commutative. So what I'm going to do here is area is equal to pi r squared. So let me replace what I know, 4.5, and I'm going to square that. Once I square 4.5, I get 20.25, and then left in terms of pi, it's 20.25 pi, and you were given this as meters, so it's meters squared. Using your calculator's pi button, we're going to do 20.25 times pi, and once we do that, we're going to get 63.61725, and round it to the hundreds place, 63.62, meters squared. For the next one, we're using exactly the same formula, the pi times radius squared. So I'm going to fill in what's given to me. This time they gave me the area already calculated. So I'm going to replace the capital A with 176.7. And then I'm going to rewrite the pi r squared. My goal is to solve for r. So I need to divide both sides by pi to isolate the r. And now, if it's said, and I probably won't give you something like this, where you're going to have to solve for r, because what you need to do now is square root both sides. So left in terms of pi, this is going to be 176.7 over pi, and then you could leave it like that for left in terms of pi. But again, we don't want a negative radius, so I'm only going to keep the positive. So left in terms of pi, that's what it is. But rounded to the hundredths place, it's going to be, once I divide this, I get 0.4996. So rounded to the hundredths place, 7.50, and these are feet. So this would be left in terms of pi, and this is rounded to the tenths place, or hundredths place. Now, again, remember, technically when you square root something, you get two answers, but we don't want a negative radius, so we're only keeping the positive answer here. Now, for these four examples, we're using the same radius length. We're using a radius length of 3 centimeters. So the formula that we're going to be using for all of these is going to be area of the sector is equal to measure of the arc divided by 360 times pi times radius squared. So this is the formula we're using for all four, and the radius for all four is going to be 3, because we got to square it. So I'm going to fill in. So my angle that's given, the measure of the arc is 50. So 50 over 360 times pi times the radius squared. Now I could go ahead and simplify. I could chop off the zeros. And then I could also do 5 over 36 now, times 9 pi, I'll square the 3. And then I could also simplify the 9 and the 36. So left in terms of pi, it's 5 pi over 4. Now let's go ahead and use our calculators as well. I know it only asks for in terms of pi, but rounded to the hundredths place, 5 times pi divided by 4, and these are also centimeters squared. But multiplied by the pi button, we would get 3.93 centimeters squared. So also use the pi button. Let's try the next one. Same setup, but this time we're going to put 20 over 360 times pi r squared. And again, the radius is still a 3. I could chop off the 0, just like I did before. I could also simplify 20 over 36 and make it 1 over 18 times 9 pi. Then I could also simplify the 9 and the 18 and make it pi over 2. So left in terms of pi, it's pi over 2 centimeters squared. And then when I use my calculator, it's also equal to 1.57 centimeters squared. So it's about 1.5 radians here. For part C, same setup. It's 140 over 360 times pi times radius squared. Again, I could simplify by taking off the zeros. You don't have to simplify the fraction. I could have also simplified with the 9 and make that a 4. And then now I'm left with 14 pi over 4. Now reduce the fraction, 7 pi over 2 centimeters squared. And then using your calculator's pi button, this would give you 10.995, so rounded to the hundredths place, 11.00 centimeters squared. And then for part D, you're going to do 210 over 360, because it's a part of the circle, pi times radius squared, so 3 squared. And then again, I could simplify the zeros. You can either choose to reduce the 21 over 36 first, or again, simplify the 9 and the 36 first. And then you're left with 21 pi over 4 centimeters squared. Using your calculator's pi button, 16.49 centimeters squared. So this time it says find the area of the region bounded by the segment AB. So segment AB is right here. And arc AB. So they want us to find, and again in the homework, it's probably going to say find the area of the shaded part. So if you want to think of it like that, find the area of that green shaded part. So what we're going to do here is, because we don't have a formula to find something like that, what we're going to do is we're going to find the area of the sector, which is right here. So I'm going to find this whole area first. And then I'm going to subtract out the area of this triangle. And we're going to be bringing back our special right triangles in this chapter. So what I'm going to be doing is finding the area of the sector. And then I'm going to subtract out the area of the triangle. So I'm going to work on finding the area of the sector first. So the area of the sector. And I'm going to be using 120 over 360 times pi times the radius squared. This is going to give me my area of the sector. I'm going to go ahead and cut off the zeros. I'm also going to go ahead and figure out 6 squared. So I have 12 over 36 times 36 pi. Notice my 36's will cancel. So the area of the sector is just 12 pi. Now I need to find the area of the triangle. So my blue triangle looks like this. It's got 120 degrees here. And then it had the 2 radii. Now, remember that when you have an isosceles triangle, let me write it maybe this way so it's easier to see. When you have an isosceles triangle, remember when you drop down this altitude or this height, it's going to be a perpendicular bisector. It works like this when it's an isosceles or equilateral. So notice, because this is a perpendicular bisector, this 120 up here is now 60 and 60. And then I have 30 down here. You are memorizing, and if I only work with, say, this side of it first, so if I work with just part of it, 60, 30. Remember, this side across from 30 is a, across from 60 is a square root 3, and then the hypotenuse is 2 times a. Well, I know the hypotenuse, it's 6. So I need to solve that equation. So I'm going to be solving 2a equals 6, divide by 2, and a equals 3. So the height of this triangle, which is my a, so the height, so for the area of the triangle, the height is 3. And then if I put 3 square root 3 here, so each of these bottom pieces are 3 square root 3. So the base of my triangle is going to be 3 square root 3 plus 3 square root 3. So that's going to be 6 square root 3. Then what you need to do is the formula for area of a triangle is 1/2 base times height. So let me fill it in. So 1/2 6 square root 3 times 3. 1/2 18 square root 3. So 9 square root 3 is the area of the triangle. Remember, at the beginning, I told you to find that green piece. Remember what we were doing here is we had to find area of the sector and subtract out area of the triangle. So the area of the sector was 12 pi, and then the area of the triangle was 9 square root 3. There were no units labeled, so this is going to be units squared. It said to leave it in terms of pi. So you would leave it in simplest radical form and also leave the pi. So this would be the final answer in terms of pi. Now I'm also going to go ahead and use my calculator, because if it says to round to the hundreds place, then you would do 12 times pi and you would get 37.691184. And then 9 times the square root of 3, so this is 12 pi, just to show you what I'm filling in here. 9 square root 3. Then this gives you 15.58845,727. And then this finally gives you 22.11 units squared. So using your calculator, it would be this, but left in terms of pi in simplest radical form, it would be the one that was boxed. And that is it for the notes on section 11.2.